In this video, I'm going to be explaining how to find derivatives of trig functions. It can be a little tricky because it requires you to memorize their derivative identities. But there is a way that we can group them to kind of help us memorize. There are what's called positive identities of derivatives of trig functions, and then negative identities. The negative identities are all of the cos, so cosine, cotangent, and cosecant. If you remember that their derivatives are always negative, that might help you memorize these. So let's start with the sine derivative. The derivative of a sine function is cosine. And if you need to use multiple chain rules, then the full identity would be this. We'll talk about that when we get to the examples. But just know that the derivative of sine is cosine. The derivative of tangent is secant squared. The derivative of secant is secant times tangent. Over to the negative identities. The derivative of cosine is negative sine, or the opposite of sine. The derivative of cotangent is negative cosecant squared, and the derivative of cosecant is negative cosecant times cotangent. So there are some patterns in there that can help you memorize these. And if you remember that the cos are negative identities, that might also help. But have those memorized and be able to use whenever you're finding derivatives of trig functions. Another thing that might help is understanding how parentheses are used a lot with trig functions and be able to rewrite it if that helps you. So we'll practice rewriting and finding derivatives of some of these trig functions. If I have a function y equals cosine of my input 3x squared, I can put that input in parentheses, and that might help us visualize the layers here, that cosine is the outside function and 3x squared is the inside function. We got to use our chain rule. Find the derivative of the outside multiplied by the derivative of the inside. So the derivative of cosine is negative sine. Keep that inside the same and multiply by the derivative of the inside. So the derivative of 3x squared is 6x. Put that all back together and we get negative 6x times sine of the input 3x squared. I haven't seen this very much, but it is possible, I suppose, that they could have the cosine of a constant value, or trig function of a constant value. That's just going to be another constant value. So we can ignore constants when we find derivatives. We would just find the derivative of x squared and then multiply it with that constant back in. So the derivative of x squared is 2x. The cosine of 3 is actually some negative constant value, and we can multiply that if necessary, but I haven't seen that very rarely. Another example might be that you are raising the input to an exponent. If that happens, just evaluate the input first and then find the derivative. So 3x squared is really 9x squared. And then we could find the derivative using the chain rule. So the derivative of the outside function, the derivative of cosine is negative sine, keep the inside the same, and multiply by the derivative of the inside. Derivative of 9x squared is 18x. Put it all back together for your final derivative. Negative 18x times sine of the input 9x squared. Whenever you raise a whole trig function to an exponent, it could be rewritten with the exponent next to the trig name, or you could put the whole trig function in parentheses and raise it to the power. So again, rewriting it in this form may help remind you that we have a chain rule being applied here. Take the derivative of the outside function, derivative of something squared is 2 times that something, and then multiply by the derivative of the inside. So the derivative of cosine is negative sine. Put it all back together, you get negative 2 times sine of x times cosine of x. And if you're taking a trig function and either raising it to a fractional exponent, or if it's inside a radical, you can rewrite it in that exponent form to help you use your power or chain rule. So take that 1/2 to the front, subtract 1 from it, and then multiply by the derivative of the inside. So the derivative of cosine is negative sine. We could rewrite this answer in a lot of different forms. One way would be to keep negative sine of x on top, keep that 2 times the square root of cosine on the bottom, either in exponent form or radical form. We could also apply other rules to our trig derivatives, such as the sum and difference rule. If I have the function y equals x minus tangent of x, I can just find the derivative of each individual term. So the derivative of x is 1, and the derivative of tangent is secant squared. So I'm left with 1 minus secant squared of x. It could also be a product rule being applied. If I'm multiplying two functions and one of them is a trig function, we could use the product rule in the same way that we're used to. Product rule says the derivative of the first function times the second function plus the original first function times the derivative of the second function. So the derivative of x is 1, keep secant of x, plus keep x and multiply by the derivative of secant, which is secant times tangent. And then we could simplify in a variety of ways. In this example, notice that both of these two terms have secant of x in them. So we could factor out secant of x and we'd be left with 1 plus x times tangent of x. These derivative identities are actually coming from other identities of trig functions and applying other rules of derivatives. For example, the derivative of tangent of x is secant squared of x. But we can actually see how we get that derivative identity by using the quotient rule on a different identity for tangent. So if I rewrite tangent as sine divided by cosine, and we use the quotient rule, we can actually see why we end up with a derivative identity of secant squared. So if you were given this function sine divided by cosine, the easiest way to do it is just recognize that that is tangent and then know your derivative identity for tangent is secant squared and you'd be done. But in case you didn't recognize it, we can actually work through the quotient rule. The quotient rule is saying take the derivative of the top times the bottom minus the top function times the derivative of the bottom all over the bottom squared. And when we do that, the derivative of sine is cosine, and the derivative of cosine is negative sine. We can then simplify. Cosine times cosine is cosine squared. Negative sine times negative sine is positive sine squared. And then we can use that Pythagorean identity to rewrite cosine squared plus sine squared as 1. So we have 1 over the cosine squared of x. That's the identity for secant. And since it's cosine squared, the reciprocal would be secant squared. So that's really where these identities are coming from, multiple identities in derivative uses. So there's trig identities and their derivatives.